Hi everyone, we are Team16 and our project is Canon Crossfire. So, so start off with our team members. We have Keen, Ryan, Hossein, and me, Sihan, and Curtis. So firstly, I'll kick off with the game concept, followed by a gameplay overview. Then the rest of the team will cover architecture, technical features, UI design, and engineering practices. So most mobile games relies heavily on touch controls, so we wanted something more physical. That's where Canon Crossfire is an endless 2D survival game where you move by tilting the phone using accelerator sensor. The accelerometer sensor. The objective is simple: survive as long as possible. Okay, next. So there'll be cannons firing from all directions. Pink color ones are the cannons, and then there's also cannonballs. As you can see, they'll shoot towards the center. That's why right now it's like loitering all in the center. And then the green color is the player. So you dodge by moving using the accelerometer, or you can like tilt the phone. So we also added kill zone, as you can see from the mobile screens, the red color square. So that's the kill zone. It's to prevent for player to go like tilting too much, and that will be game over. Or if you get hit by the cannon, it's also a game over. So your score is also based on the time survival. So if you hit or you go out of the bound, that's it. Yeah. So now I pass on my time to Kosen.
For our system architecture, it follows a clean layer approach. Jetpack's compose UI connects to a view model, then a repository layer, and finally, room database plus networking. This separation makes the project easier to maintain, scale, and test. Next. So for our first technical feature is the sensor integration. We use the sensor manager with the accelerometer to read tilt input in real time and translate it into smooth player movement. We also included calibration and sensitivity tuning, so the controls feels more consistent. Now I'll pass on my time to Kim.
Thank you, Kosen. For the core gameplays, we run through the game loop using coroutines for smooth updates. The game manager handles spawns for the cannons, cannonball, and coins, and collision. And collisions are checked using distance space formula. We manage flow using states like ready, running, and game over. For the next technical feature we have is the database and networking. We utilize a room database to manage local data, structured with specific tables for both users and scores. This allows for local high score persistence, meaning your best runs are saved directly on your device, even if you are not connected to the internet. On top of that, we also support an online leaderboard using async network calls, keeping the app responsive while sending and fetching data. Now I'll pass on the time to Brian.
Okay, thank you, Keen. So for our UI and design, so overall in our game, we have a main menu, a pause screen, and a game over menu with a high score leaderboard. So this will be showcased later in the actual demo. So our interface is built fully in Jetpack Compose. We will focus on responsive layouts across devices. And we kept the UI clear so that gameplay can be seen clearly during fast movements. Okay, next slide. So for our software engineering practices, so for our source control, we use GitHub, and we also have feature branching. So each of us doing our own features have our own branch. We also have modular architecture. So the code is structured around the model view model, kept modular and follows consistent Kotlin styling for readability and maintainability. Okay, next slide. Okay, so for challenges and solutions, so for our sensor sensitivity issues during the control of the player when you're tilting the phone, so we just basically calibrated that while testing during gameplay. For collision accuracy, we refined the hit detection so that we do not get any weird sort of collision issues where the cannon is not hitting the player, but collision was detected. For networking delay, we use a coroutine. And for UI blocking, where the UI freeze, we basically move heavier processes to the background thread instead of the main thread. And now I'll pass the time to Curtis to talk about our demo.
Thank you, Brian. So I'll be showing you the game demo that we currently have using an external phone. So this is our game app. I'm not sure if the audio is audible, but there is audio. So this is the main menu that we have. Start the game. And you're basically dodging all the cannonball while trying to gain a higher score and surviving, and collecting points for extra points. So at the end, if you die, I'm not. Well, I am on the leaderboard actually. So I can input my name, and I will update the leaderboard with my name there at number 5, as you can see. So this the gameplay is done with the accelerometer. And back to menu, you can just replay the game again. So that's our game demo. And now I'll be moving on to the conclusion. So for our conclusion, to conclude, we delivered a native Android game with 3 advanced features: sensor controls, database persistence, and networking for an online leaderboard, as shown in the game demo earlier. We also applied a clean model view model architecture for maintainability. In future, we can expand with more patterns, items, and progressions. Thank you.